The industry's origins in the United States can be traced back to the late 1800s, and more specifically the early 1900s, with the advent of electrically welded steel pipe. In North America alone, about 300,000 miles of these mostly underground pipeline systems transport huge amounts of natural gas each day, serving as the critical link between fuel-producing regions and end users. The pipeline systems continually evolve, being updated with the latest proven technologies as demand warrants or specific area changes dictate. It's more and more commonplace for population and development to grow toward what were once rural pipeline systems. For that reason alone, it's more and more important for all stakeholders to recognize and respect these important underground facilities. One of the leading causes of pipeline incidents is careless excavation practices. Preventing pipeline damage has become a major focus area for operators. Bureau of Transportation Statistics records have historically and consistently shown that long-haul pipelines have the best transportation safety record in the United States. Pipeline system accidents, which are reported to PHMSA, are rare, particularly when one considers the trillions of cubic feet of natural gas transported each year. But the industry fully understands the potential impact of a damaged pipeline and takes many measures to both maintain pipeline systems and prevent these accidents from occurring. The industry has built its solid safety record on a foundation of continuous improvement, and as a result, it has seen a percentage decrease in the number of significant incidents in the past 20 years, while the amount of natural gas moved in that time frame increased dramatically. Every step of the way, these long-haul pipeline systems are monitored around the clock by high-tech equipment and highly skilled employees. The basic process to transport natural gas long distances involves not only the specialized steel pipeline, but related measurement and pressure regulating equipment, compressor stations that compress the natural gas molecules to facilitate the journey, and control centers that monitor major operating conditions around the clock. Companies also repeatedly communicate with those living near pipelines, emergency responders, and other important stakeholders through various methods, while providing strategically located above-ground markers and other means to remind them of their mostly underground assets. An object-free and clearly defined right-of-way corridor is critically important to pipeline companies both during the construction and operation phases. While a temporary workspace width of about 100 feet is generally required during construction, the permanent right-of-way for a long-haul natural gas pipeline is typically 50 feet wide or roughly 25 feet on either side of the buried pipeline. This helps identify the presence of an underground pipeline. On the right-of-way, work site preparation begins with the removal of all trees and brush from the construction work area. Stumps are removed over the width of the permanent right-of-way, with the exception of stream buffers and wetlands. Specialized heavy equipment is often used to assist in this process. Downed timber is often cut into usable lengths or otherwise disposed of after seeking landowner input. Grading is conducted where practical to provide a relatively level surface to allow safe operation of the heavy equipment required to excavate the trench and install the pipe in the trench. A trench is excavated that is wide enough to safely support the depth of the trench and to allow lowering in of the pipe without damage to the pipeline coating or harm to construction personnel. In some rocky areas, blasting will be required to excavate the trench. The steel pipe sections, or joints, in 40 or 80-foot lengths, are trucked to the construction work area and strung out along the route in the areas where they are to be welded together. As necessary, the pipe joints are bent to follow the route of the pipeline and contours of the ground. A specialized pipe bending machine is used. The amount of the bend in the pipe section is limited to avoid damaging the pipe or coating. Once the individual pipe joints are bent to fit the trench, they are welded together into long continuous sections which can be up to several thousand feet depending on terrain. The welding is highly controlled and performed by welders using proven international standards. Each weld made on the pipeline is visually inspected, and the welding process is verified with either radiographic or ultrasonic technologies. Welds that do not pass stringent requirements are repaired or replaced. A specialized corrosion protection coating is applied to each of the weld joint areas after the inspection is complete. The coating on the entire pipe section is then electronically checked for any coating problems and repaired prior to lowering the pipe in the trench. The pipe sections are lowered into the trench by special pipe-laying tractors called side booms. Care is taken to not damage the coating during this process. The pipe is placed in the trench on sandbag benches to prevent damage to the pipe coating. The coating is rechecked again. The ends of these completed pipe segments are then welded together in the trench to form a continuous pipeline. Once long sections of pipe are completely in the trench, the material excavated from the trench is carefully replaced over the pipeline. A layer of rock-free pad dirt is placed all around the pipe to protect the coating. As various sections are completed and the trenches are backfilled, the pipes are filled with water and safely pressurized to a point significantly higher than the maximum pressure the pipe will ever be operated to verify the overall integrity of the pipeline. This test pressure is held for a minimum of several hours to test the structural integrity and overall strength of the pipeline, and to allow minute water leaks to be found. The cleanup and restoration process starts as soon as practical after the pipe trench is backfilled, and continues until the construction work area is restored and revegetated. All terrain is replaced to original contours as much as possible, and the work area is restored utilizing seeding and soil preparation specific to the affected area to restore ground cover and to minimize erosion. Temporary workspaces will be allowed to return to their previous state, either wooded or open. The permanent right-of-way corridor will need to remain free of most obstructions to signal to any passerby that underground utilities are present. Above-ground markers will be placed at locations such as road crossings and at various strategic places along the route to further indicate the presence of a pipeline. The markers contain important information such as operating company contact phone numbers and the commodity being transported. Upon completion of construction, the right-of-way typically may be used for most residential, commercial, or agricultural purposes, provided this use does not interfere with the safe operation, maintenance, inspection, and repair of the pipeline, or obstruct access to and along the right-of-way. Restrictions are documented in the easement agreements, but in general, permanent structure should not be placed on the right-of-way. Some examples of these types of obstructions include houses, decks, sheds, pools, and septic tanks. Also, tall vegetation or trees should not be placed on or near the right-of-way. Some items, such as driveways, fences, and improved parking lots, may be placed over and across a right-of-way if they meet certain requirements to protect the pipeline. Always check with the pipeline operator and easement restrictions prior to beginning any work.